question, a toy car of mass 0.5 kilograms racing around a circuit with a properly banked curve, right? Properly banked curve. Radius of curvature r is 0.35 meters, and the angle is 30 degrees. Okay. What is the normal force on the car? Let's start with an FBD, and what is the tangential velocity of the car? Okay. So for the FBD, first is definitely it will have a normal reaction, something looking like this. It will have a gravity force, which is something like this. And then we have to, of course, make the components of the normal force. So the components are going to be looking like this. So we have to be a little careful about the angle. So since this is 30-degree and these two are parallel, I mean, I'll just draw it once again. These two are parallel and this is a transverse. So it means that whatever this angle is, the same as this angle, right? Because they are alternate angles. So that's going to be, that means that this is also, if we extend this up, this is also 30 degrees, right? This is also 30 degrees and this is the normal force over here. Okay, so if this is 30, then this means that by extension, if this is, I mean, I'm just going to draw it separately over here. So this will make a better understanding. This is 30-degree. This is the normal reaction. Normal means that's going to be perpendicular to it. And this is over here. So this is 30. That's what I'm saying. And since this is 90, so this is going to be 60-degree, which is exactly what we need. So this is 60-degree, which means that the components are going to be Fn cos of 60-degree and Fn sine of 60-degree, right? Sine of 60-degree. So now it's relatively easy. What do we have to find? We need to find the normal reaction. So definitely the perpendicular, I mean the vertical forces should be same, which means that Fn sine of 60-degree should be equal to mg. Which means that Fn times sine of 60 is nothing but root 3. In fact, let's not do that. Let's divide both sides by sine 60. So that's mg over sine of 60-degree. Mass is 0.5, gravity is 9.8, and sine 60 is, let's keep it sine 60. And that's where the calculator comes in. So zero point 0.5 times 9.8 over sine 60 comes out as 4.9. 4.9 newtons. That is the required normal force, which is needed in part A. And in part B, we need the tangential velocity. So remember this required, the force which I highlighted is providing the necessary centripetal force, right? So that's going to be Fn cos of 60-degree will be equal to mv square over r. Fn we already found is 4.9. Cos 60 is, we know it's 1 over 2, or we can use the calculator as well. M is zero point 0.5. V is something which we have to find, and the radius is given as 0.35. The radius of the curvature over here is given as 0.35. So all we are left with is just the calculation part. So let's, I think, cross multiply. So 4.9 times 1 over 2. 1 over 2 can be written as zero point 0.5. This 0.35 gets multiplied with this, so 0.35. And dividing both sides by zero point 0.5 we have over here, and this is equal to v square. And that's where the calculator comes in. So let me just grab my calculator and try to find this up. Times 0.35 over zero point 0.5. And the square root of this value, because we have to take square root both sides eventually to get the value of v. So I'm getting 1.31 is equal to v, which means that the tangential velocity is 1.31 meter per second, which is the answer to part B.